So we're going to very quickly talk about finding the area of a triangle instead of using the base and height, doing it using trig. So this is the trig style area of a triangle. So earlier we learned that the coordinates of a point where an angle intersects a circle are a, when the radius is a, are a cosine theta, a sine theta. And that's when you have anything like this. So you have an angle coming out here that they call theta. The coordinates at this point, if it's on a circle somewhere, are that right there. So no matter what your triangle looks like, we're going to figure out how to find the area of it. So we know that A is going to be the radius, so A has to be that side, making this capital A. Let's call this angle B, this angle C, making this side lowercase c and this side lowercase b. And we could drop an altitude down here, and if we did that, our y value there ends up to be this piece right here. So the length of this side is A sine theta, which is in this case angle B. So A sine B. Now if we're trying to find the area, the formula we know is A equals 1/2 base times height. So if we plug in our base, well, the base of our triangle up here is the bottom, which is lowercase c, and our height is that yellow piece, which is A sine B. So when they put this on your reference sheet, for some reason they change it to K, maybe so that you know it's a different formula, but it's K equals 1/2 AC sine B. And again, they'll only give you one form of that, so you're going to need to manipulate it as you see fit. So it might be K equals 1/2 AB sine C, or 1/2 BC sine A, or what we just wrote down, 1/2 AC sine B. The important thing is that you have all three letters, A, B, C, A, B, C, A, B, C. Each one of them has all three letters in it. So the area of a triangle, I'm actually going to have you cross that out because we don't really need to fill it in. It just says in words exactly what was in the formula there. So let's look at this example. To find the nearest square foot, the area of a triangular lot of land at the intersection of two streets. So here's our two streets. If the angle of intersection is 76 degrees, and the sides along the streets are 220 and 156. Now you can label these whatever you want. So I'm just going to pick A, B, and C, and I'm going to go ahead and assume you can't see that, so let's change it A, B, and C, and then I'll fill in my lower cases. Lowercase c, lowercase b, lowercase a. So if I'm looking for the area, in this case they give me angle A, so I'm going to use K equals 1/2 BC sine A. And then I just plug in what I know. So I know K equals 1/2, B is 156, C is 220, and angle A is 76 degrees. Now, just like the law of cosines, you can take that whole thing, making sure you use parentheses, and plug it all into your calculator. So you get K equals about 16,650 feet. So again, once you draw your diagram, label your sides up, pick which form of the formula you want to use, and then just plug it all into your calculator. Let's look at one more example. Find the area of triangle ABC. So let's draw our triangle. If side B is 19, side C is 25, and angle C is 95. Now, right away, you need to be careful because they have given you B, C, and C. So you cannot use law of cosines or law of sines because they've given you an angle side pair here. And if you have an angle side pair, that immediately means that you're going with the law of sines, which says A over sine A, B over sine B, C over sine C. So we'll plug in what we know. Well, we don't know lowercase a, we don't know capital A, so that's out. We know lowercase b is 19. We don't know angle B, so that's sine B. And we know C is 25, and angle C is 95. So I'm going to do a little bit of my cross multiplication here. And I end up with 25 sine B equals 19 sine of 95. And I can plug that in my calculator to get 25 sine B equals 18.92769926. Next I would divide so that sine B equals 0.75710.79705, and I know I'm running out of room. To get rid of that sign, you have to use arc sine, so that these cancel, and I get that angle B is about 49.2 degrees. So that gives me this angle. Now I need angle A because they've given me this side and this side, so I need the included angle. So to do that, I would do 180 minus 95, which is 75, and then I would subtract 49.2. So I would get that angle A is about 35.8 degrees. And now you could plug this back in to your K equals 1/2 BC sine A. We will finish that up in class tomorrow. So I hope you have all this. What I'd like you to do right when you come in, before we even do an index card quiz, is plug this into a calculator and see if you can figure that one out. We will go through example 3 in class, but what you can do before that is actually cross out this whole piece right here, because we're not going to talk about the other formula that can be used. The area formula works just fine. So we will do example 3 in class. Please make sure you finish up example 2 as soon as you get in. I will see you tomorrow. Have a wonderful evening.